Uh, hey everyone, I hope the audio is clear this time. I think there was some issue. The software did not uh, propagate my audio, so yeah, I'm live again. Let me just start over. Hey guys, welcome to the Sway Community Call, a second session of which we are doing it right now. And in this session, we will be discussing reentrancy attacks. So yeah, let's just quickly get started without much further ado. Let me just share my screen really quick. Perfect. I hope the audio as well as my video is clear this time. Yeah, it seems. So yeah, let's talk about reentrancy attacks. Firstly, I am Nazi and I'm a solution engineer at Fuel. Secondly, let's first see the attack history. So as we all know, GMX got attacked like a couple of days ago, and again it was the classic reentrancy attack. And there was also like many attacks. One of them was the Dow hacks. That was again the victim of the reentrancy attack. So there were like a lot of other attacks as well, but I have not mentioned all of these. So overall, reentrancy is one of the I would say oldest problems in the blockchain history that we are encountering. So yeah, let's first see what is reentrancy attack. So reentrancy is a vulnerability that occurs when function makes external calls before updating the state. And it will do, this will create a window for the same function to get called again multiple times and without the updation of the state. And what does that leads to is the drainage of funds from the entire contracts. So yeah, let's get into like how the whole attack looks like and what's the flow. So for the whole reentrancy attack, firstly, the attacker calls the vulnerable function. Let's consider withdraw function for the sake of understanding. And this withdraw function makes an external call for sending ethers, and what it will do is this external callback function again call the original function, a withdraw function in this particular case. And this original function will get execute again because the state has not been updated yet. And what it will do, it will repeat this process until all the funds are drained. And yeah, it becomes the victim of the reentrancy. Now, this is the whole diagram of the what reentrancy attack looks like. Attacker will call the withdraw function. This will make external calls sending funds to the attacker, and this will again go on in a loop, and the funds will get drained. Now, let's understand how reentrancy is being handled in Sway. Now, Sway provides significant improvements over Solidity, like both through its architectural designs as well as compiler level analysis. Now, Fuel does allow reentrancy, but it provides better detection capabilities. Firstly, transaction gets a fixed memory size. So what happens is like when external calls are pushed as call frames, contract can detect reentrancy by checking if they appear in previous call frames. So let's say if the contract detects that they have appeared in the previous call frame, then they detect reentrancy, and yeah, like it takes care of it. Now, what are the key differences of Sway from Solidity? Firstly, cross-contract reentrancy via token contracts are impossible in Sway. And why? It is because the use of native assets. So in Solidity, you have a token contract to make the transfer of any asset, right? So there is a chance of reentrancy. But as Fuel uses native asset, it does not require a function call to transfer the asset. And by that, you can avoid the chance of cross-contract reentrancy via token contracts. Secondly, compiler automatically detects for the violation of checks, effects, interaction patterns, which is also known as CEI patterns, and issue warnings. Now, what does CEI patterns means? We will see that in a bit. And thirdly, functions require explicit storage permissions. For example, let's say I want my function to only read the value, then I will not. like that particular function call will not be able to change or update any value in the contract. Now, let's say if I want my function to update the state, then I will have to explicitly annotate uh, with this tag, so that it will tell my function that okay, like this function will have permission to update the state, and it will only allow then. And fourthly, algebraic type safety between EOAs and contract IDs. Now, what does that mean? So, in Sway, if a particular contract is expecting a call from EOAs, or like only allow to get call from EOAs, then if a contract will try to call it, it will not allow that. Similarly, if a particular function is being expected to get call from contract ID, and if an EOA will try to call that function, it will not let that particular call get through. So it will block that, and thus it provides you additional safety. Now, let's come to CEI pattern. What is CEI pattern? So CEI stand for checks, effects, and interaction. Now, whenever we have this external contract call, there is a certain pattern that we have to follow. Firstly, check. We need to check if the particular state of the caller is true. For example, if the caller has a sufficient balance to withdraw. Secondly, effect. Whatever effect it has on the current contract, just do it before making the external call. For example, update the state and decrement the caller's balance in mapping before making an external contract call. And thirdly, interactions. So if the checks pass, perform an external call after the effect. So this is the CEI pattern in a nutshell. So now let's understand how Sway compiler handles reentrancy. So let's consider this code snippet. We have this ABI, and we are creating an instance of this other contract. And what we are doing is we are making an external contract call. And after that, we are updating our balance in this contract. So as you can see, we are violating this EI pattern. We are checking the condition. We are making the call first and then updating the state. So what the Sway compiler will do, it will give the warning at the compile time itself. As you can see, I have commented the warning over here. So it will give the warning on the compile time itself, and you can just not ignore it and prevent or like take preventions in order to avoid the reentrancy. Now, how does Sway itself helps to prevent reentrancy? Now, Sway provides Sway library. Like Sway comes with Sway library that provides reentrancy guard library. And let's consider this smart contract, right? Like I have my ABI as well as my smart contract. Now, Sway library offers two functions, reentrancy guard and is reentrant. Now, let's say if I do not want my particular function to be vulnerable to reentrancy, then I will just call this function. Yes, it is that simple. I just need to like import it and call it in my function, and it will panic if the reentrancy is detected. And like creating a panic will like revert the entire transaction, like entire state changes in a transaction. Now, secondly, is reentrant function. It will return Boolean value, and it will return true if the current call frame or like current call is reentrant. So like these are the two functions that Sui library provides to guard your contracts from the reentrancy. So there are like basically two reentrancy protections that Sui has. First on the compiler level, second on the in the library. And of course, like cross-contract reentrancy via contract calls, like token contracts are already impossible due to native assets. So these are like multiple measures that Sway comes with in order to help you prevent reentrancy. So I am not saying like Sway or like Fuel VM completely prevents reentrancy, but it provides you a lot of tools to prevent it. So that's, yeah, the topic of reentrancy and how Sway handles it. I hope it's clear with all of you. And yeah, I guess see you all in the next session. Until then, bye bye.